So, Assalamualaikum everyone. Here, back to Sunday podcast again with me, Adil, and this time I will be the host while Andra will be the guest and Haskuchi will be the note taker. So, how are you doing, guys? Are you doing well in your place right now?
Yes,
Yeah,
but we are doing well right now.
we
Thank you.
are fine, thank you.
I see. That's nice to hear, man. So, today we're going to discuss about Voltaic cell. Now, Andra, what is Voltaic cell? Can you please explain that to us?
Yeah, voltaic cell is a cell that will produce some electricity called spontaneous reactions. So when the cell runs, that means it will, result electricity that we can use for example in battery or things that we usually use for power the our mechanical problems with the electricity.
Mechanical problem with electricity.
Yes. Yeah. For example, like let's say you have you have watch. You have watch. Okay. And if you want your what is jarum?
Oh,
Oh,
the
pendulum.
Needle, needle.
Not
Yeah.
pendulum. I
If
guess.
you want your needle to move,
Needle.
then you need the power. And what power is from? The power actually is from electricity, and
uh,
the electricity can be produced from the battery that is already installed, like uh, the plates battery inside your watch, and that kind of power can move your mechanical problem.
I see. So you
Yeah.
mean like this voltaic cell is the one who is, one of the way to make a battery, and this
Uh,
battery is one of the way to do some mechanical stuff.
yeah,
And
like uh, moving your fan, moving your like uh, your wheel in electric vehicle. That's how it works.
I see, I see.
Uh, or
So
just make your processor run smoothly inside your laptop.
I
mhm.
see, I see. So this voltaic cell is the underlying theory behind the ion battery and stuff, right? It should be like that, right?
Yes. Yeah, you are very true, man. Yeah, you're right. Sorry.
Yeah. And this with this the ion battery, I mean, we can make a long life, batteries for electric car, for laptop, MacBook
Yeah,
laptop
even in
especially.
HE water,
What? Etsy? What?
AQ water,
Eh,
like the power inside your conventional vehicle.
Yeah, yeah.
Aki,
oh, SU, yeah,
ACU,
HU.
SU.
Yes.
the
Yeah.
Okay,
car battery, basically.
Yeah, you are very right.
That's the
Yeah.
yes. Yeah.
I see, I see. So, how does it work, Andra?
Okay. First of all, I wanna show the presentation first with uh Figma. Have you ever can you see the
Oh yeah, yeah,
board
nice, nice. Can you
Nice.
share us the link?
link?
Yeah,
Oh, okay, okay.
my new laptop right now can do touch screen, so maybe I
Oh,
can use it.
it's good to see it.
Yeah, I've been by this stylus pen.
Nice. I
Yeah,
not
I
that.
No,
already
not Google Meet, man.
sorry, sorry,
Yeah.
sorry, sorry. Oh, okay, okay, sorry. I forgot about it. I forgot to copy it. All right, so I already sent you the Figma
All
link
right, thank you so
in comment
much.
section.
Let me join it. I click here and yeah. All right. So what is this?
Okay, wait.
Okay, let's see.
Oh, where are you guys? I mean, are you supposed to get there?
I'm
No, I
Oh,
see.
Oxygen is already in.
I'm loading
Thanks.
right now, but
Oh, loading.
I see. Yeah, I get it.
why is
Oh,
it
Yeah,
not
I mean,
loading?
I'm still learning for using Figma, so
Oh
I hope
yeah,
that,
yeah,
yeah,
that's fine.
maybe if I ask a question about Figma and hope
sure,
you
sure.
guys help.
Yeah.
Okay, Adil and Haskuchi are already in, so I will start the explanations of what voltaic cell
Uh,
means in real life.
can you give us the permission, Andra, to
Oh,
write?
permission.
What? Hmm.
Can you? I'm view only here, Randy. Are you also view only?
Yeah, I'm few only too, but I can use C though. Like,
Okay. Well, I mean, I'm quite confused
It's
to
it is it's supposed to
let
be in
you
share button.
able. Huh?
In the share button, click the share button, I guess.
Oh, share button. Okay.
And then
Alright.
change the
can
Oh yeah,
change
you
the
can
yeah,
edit.
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 Oh,
Yeah.
okay. You don't have edit access to any project, so you can move this file. Gen or click team.
What?
What?
Try again.
Oh,
Wait, click again. Can edit?
When I press the button of can
okay,
edit,
okay.
the the pop-up says that you don't have edit access to any projects, so you can move this file. Join or create a
Oh,
team.
you have to name it first, I guess,
Name it. Oh,
instead of untitled.
How about you just
The
auto
file.
add edit of
huh?
it? Oh yeah, no. You can't. So Figma have this policy of so this is in draft, right? Basically, there are two types of category in Figma. The Figma, they are your file usually in draft, and then
Oh,
you move it into uh, the files in Figma, which basically you can add editor there. But if you want to add editor, you have to buy their premium plans to add editor in the files, basically
So you
something like
mean
that.
like Andra will be I and Renia will be able to become an editor here?
I think so because Andra does not use like
oh,
university account or something like
oh,
that.
yeah, okay.
Oh, I
So,
see. It
okay,
is.
never mind it. I mean, I will execute the explanation first.
Yeah. How about
Mind
you?
it?
Just
All right. So, okay. Uh, voltaic cell, or we can say
yeah.
galvanic
Mhm.
or voltaic.
Oh
Okay,
yeah,
got it.
voltaic cell, galvanic
Sorry.
cell.
I okay. I mean, I wrongfully write it.
You
Or voltaic cell. Okay. When you say voltaic cell, I mean it can refer to galvanic also, but we know in this case, I mean we prefer to say voltaic instead of galvanic. Right? So let's agree with this term.
mhm.
Okay. So hello guys. What actually voltaic cell means? Okay, voltaic cell means it's a redox reaction that will produce the electrical chemistry, right? So it's kind of you transfer from the chemistry to the chemical reactions to electricity,
Mhm.
right? Uh, and when you say that you produce the electricity from the chemical reactions and the cell is actually spontaneous.
Spontaneous. I see.
Spontaneous, yeah. All right. Remember this. As we already learned from the previous lessons, okay, so the cathode here is such a reductions. All right. So what is reduction mean?
your
When
electron
Huh?
is decreased, right? Or
Electrons
it's not increased in
increase. Yes, it's
fact.
increased
Yeah.
actually.
Sorry. That's right.
What about the oxidation number or oxidation states in the reductions condition?
So the oxygen is increased, which means the electron is decreased.
Actually, when it comes to reduction, the oxidation number
Yeah, decrease, right? But
decrease, but
oxidation,
the
the on oxidation is increased.
electrons increase.
Yeah, it is the complement of it.
Yeah.
The,
Uh, and the oxidations. Okay, the oxidation here means that well, I means you know it is such a it refers man. It refers.
what?
Actually, anode here. Okay, and oxidation here.
Now hold on a second there, cowboy. So cathode is reduction, anode is oxidation.
Yes. Cathode is reductions. All right. So the anode is oxidation here in voltaic cell. So like you say oxidations. Oxidations means that the oxidation number is increased, man.
Mm-hmm.
It's such the reverse of the reductions, and I actually use these terms. Okay, the compressions. Okay, like karet.
Correct.
Yeah. When
Oh,
I was in high school, karet means cathode reduction. Cathode reduksi. To remember this,
oh yeah, karet.
yeah, the principle. Yes, cathode reductions, and it works for both voltaic cell and electrolysis. Okay, so when you say cathode, it must be reductions.
Must be
mm,
reduction. How
Yeah, when
about
you say
cathode?
cathode, it
Cathode.
must be reduction.
Yeah,
Yes,
cathode.
but see, about the pole here, uh, it's not really the same as caret. So in voltaic, you see pole plus is cathode, but in electrolysis, pole plus can be anode. So
Oh yeah.
to make it easier, I usually use this term or compression, kapan. All right. So
Oh yeah, that's right. Kapang.
yeah,
Yeah, you have to say it in French accents. In French accents, if we face N, it become so kapang.
kapang. All right.
Yeah,
Yeah. So it's look like cathode cathode
mm-hmm.
positive, and another negative.
Okay, got it. Got it.
Yeah. Um. Okay. We see in an example here. All right. So guys, here the example of the voltaic cell systems. You see, what is the device that I'm actually hitching here?
salt bridge,
Yeah,
salt bridge.
it's called salt bridge
A
or jembatan
bridge.
garam. Yes, the function
So,
of salt bridge is to neutralize the excessive amounts of anions or cations in both sides. So the reaction can continuously work without any stop in the middle of uh, electron transfer.
Oh
Okay,
yeah, to neutralize.
to neutralize. Okay, and in order to understand about voltaic cell, you need to understand about the I mean
mhm.
the list of electrode voltage like this. Okay, hold on.
List of electrode potentials.
Okay, I mean, I will make it easier to see. Sorry. Okay, in this category, you can you see the electrode voltage list here?
Oh yeah. What is
Yeah,
it?
that means that the higher you have voltage, that means it's more reduction. It is presented by the red arrow as a stronger oxidation agents. All right.
Oh, I see. So the
Yeah.
lower it is, the stronger reducing against. So it
Yeah,
Mm.
will.
the stronger reducing agent, or it is oxidation.
Oh yeah, it will
Yeah,
do
it express.
oxidation with the partner. Wait, 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 wait.
What
Yeah,
is this
What is that?
and
EV?
EV. Oh,
Like,
EV
yeah.
is the voltage, the cell
Oh,
voltage.
so
So
voltage.
um, an example, right? You see the can you see my
Yeah,
cursor?
yeah. I can see your cursor
Oh, okay. Uh, where's my cursor located?
at
In
the blue.
Oh
to
yeah,
H
the
plus.
blue. Yeah, the blue means that it's such a benchmarks, the benchmark of voltage, like
Mm-hmm.
hydrogen cell reactions. All right, so you see that two hydrogen plus two electrons is
Mm-hmm.
hydrogen, and the EV is zero, man.
Okay, got it.
Okay, so uh, when the voltage is more than zero, it means it is positive voltage, but if it's lesser, then it is negative. All right. Now you need to see and be concerned about the uh, argentum or copper reaction here.
What?
Okay.
Uh, Argentum is a copper, bukan not Cu.
Not silver.
Cuprum.
Oh, oh, sorry. Yeah, argentum is silver. Sorry.
Oh yeah, yeah.
You need to be concerned
Okay.
about the argentum here. You see the reactions
Yeah.
0.8 voltage, right?
Right.
Mm.
Okay, and now second magnesium. You see, it is minus 2.37 voltage, right? So what do two reactions mean for you guys? Uh, which one is reductions and which one is oxidation?
The
I think the Mg is an oxidation,
mhm.
while
Mg
Ag,
oxidation,
well, Ag is the reduction.
Mg Mg oxidation,
Yeah,
and Mg
is the
reduction.
otherwise reduction.
Oh, otherwise, okay, yeah, you are right. You're right. So yeah, you see that Mg and Ag, if they are combined into one reactions, and we need to determine whether that will be a reductions and oxidations. Simply, you see uh, the voltage amounts here. If the voltage is more positive, is the voltage is more positive, that means the substance is reductions. Simple. All right. So in example like this, we are gonna get back to the board, and all right, guys. Can you see the?
Yeah. No. Yeah.
Can you,
I can see it.
all right. In this board, you see that MgSO4, all right, and the AgCl here,
Hmm?
and we have electrodes between magnesium and silver.
Yeah.
Okay, so before we can make the reactions, we need to write the base reactions according to previous table that we already saw. Okay, let's
Okay.
say let me write it first. Ag plus uh, Ag plus
Mg.
plus one electrons is Ag, and
Second reaction.
EV, yes, EV, or the voltage of this cell reactions is 0.8 voltage.
Okay.
On the other hand, when you talk about magnesium, all right, magnesium here, just write it like this. Uh,
2E equals Mg. EV should be
uh, minus 2.37 volt. Yeah,
oh
like this.
Wait,
All right.
why does
So
it is? Wait, oh yeah, yeah, that's right. Never mind.
okay.
Adil, can you move your hand there?
What? Oh
Your
yeah, yeah.
cursor.
I'm sorry. I'm sorry.
Yeah, okay, got it, got it. All right. Okay, so it
Okay.
shows.
Uh, first of all, I mean, we need to uh, make the combination reaction from this category. All right. So uh, let us rewrite it. Okay. Ag plus one electrons equals silver.
Wait, hold on. We are going to measure the what the galvanic. Wait, what is AV again? It is volt.
It's
Voltage.
voltage between voltage in a cell.
I see.
Like you see silver, in silver we has in filter, and in silver we have the voltage is about 0.8 voltage. However, in magnesium we have the voltage equals minus 2.37
Yeah, I
volt.
mean we are going to measure what is the voltage that will happen, right? If
Yeah,
we
from
do these
this cell.
two stuff. Oh yeah, yeah. Like if with this, if it is very very high voltage, we are going to feel zapped, right? Zap. What is setrum? We will feel,
Electric shock,
yeah,
or
we'll get electrically shocked by this. Uh,
but when the volt is under 5, it's still safe, right?
oh, it's still safe. I see. So just little, just little shock. I see. Yeah, no harm, no harm.
No harm. All right.
I see.
Okay. Let's say, okay. First of all, we need to determine which one is anode and which one is cathode from this voltage. Can you guess?
Well,
Remember that cathode is reductions.
cathode is reduction.
All
Oh,
right.
so it should be Mg is cathode while Ag is oxidation.
So the cathode is Ag, right?
Oh, so Ag is the cathode.
Hold on. Sorry. Mg. They both reduction, no?
No, there is not two. This is 2A not 2A minus.
Oh, simply I
Oh,
forgot
this
what.
is 2A minus.
Yeah,
No, this
it
will
doesn't
be
matter.
very hard.
All right. So what the cathode is silver, and then
Wait, what makes the cathode silver?
what?
I
It is
mean,
because you see that you see from the volt, okay.
Oh, you see the fall, not the reduction
oh,
from
not
the
the
half
electron,
reaction.
not the electron.
Yeah,
Thought,
because when you see the okay, all right. So see the list here, okay.
Yeah. I mean, yeah, the list
All
shows
of
that.
them is uh like if you see the reactions, it must be reduction, right?
Mhm.
But because it is such uh, just the reduction half reaction. So what you need to be concerned is from the voltage.
Oh, I
Okay. From the
see.
voltage, you can determine whether this cell is gonna be reductions or oscillations in order to make the voltaic cell.
So Ag, because it is in the upper side, it is cathode because it is
Mm,
the
you're
reduction.
right.
The
Yeah.
oxidizing agent.
So everything above H plus, above hydrogen, is basically a cathode. Is it?
Uh, it's not necessary. It's not necessary.
Or not
Let's say
necessarily?
let's say we have cuprum or copper, and we have Sn or tin. You see, Cu and Sn.
Yeah.
Which one is the reduction? My question.
Oh, it should be Cu who will
Ah,
be the cuprum who will be the reduction, while Sn should be, what is Sn again? I
tin,
forget.
tin, tin.
Then it should be the oxidator. Oxidation happen.
Oxidations. Yeah, it is. It is very very right.
That
So
is
it's not
correct.
necessary to say that all of the compounds above the hydrogens is reductions. It's not necessary because when you compare between two substances, you need to see from the voltage, the volt, which one is higher, and it's gonna be reductions. That's it.
Oh, that's how it works. I
Yeah,
see.
of course, of course. Okay. But okay, I will explain it later. First of all, okay, we get back to our the initial board.
Alright. So we're going to.
Oh my god, the time is here and okay. We see the cathode is here for silver
Ag.
and the anode is for magnesium. All right. Beforehand, before we make it as a complete reactions, we need to uh, let's say equalize the coefficients between cathode and anode.
Oh, I see.
So
Equalize. So
uh,
we've got to, you know,
we need to
multiply it
multiply
by
it,
2.
yes, to make it equal,
I see.
and we get
It is the
um,
elimination operation, right? Elimination operation. And
yeah. Okay, to make it easier, from this we need uh, to change the reactions first because the reaction is still uh, reduction half reactions. We need to change it like this: G Ag plus, because the anode is oxidations, then we should reverse it.
oh, so we've got to reverse it.
Yeah,
Oh, I
and never
see.
mind it first. Never mind it first. Okay, after you have the complete proper reactions, you need to equalize it in terms of coefficients. Uh, okay, maybe oh, sorry, because you see that the ion here, the ion the ion of silver is still one, then you should add two here in order to make it equal in terms of the uh, ion.
And it
And
will
here you
be
put
4. No, no, one. That's right.
one, yes.
I see. And then we going to eliminate the electron, and the result will be.
Oh yeah, it is for electron. Sorry. So uh, you got the electrons is equal.
I see.
Yeah. You are very true. You are very right. Uh, what is this? just now to make sure it is true. 2 egg plus
2 MAG plus.
2 mg plus the mg2 plus 2e. All
E.
right.
Okay.
Resulting.
Resulting eliminate the electron and just write about the complete reactions.
Got it.
Means why my writing is so broken. What is
I see.
2ag plus
okay?
mg
To
reacted reaction
all
is
means my neighborhood is now gonna get experience about the what is the smoke for attacking the mosquito.
I see.
oh yeah
Okay,
got
I
it.
mean I need
You
to stop. I need to close the windows first.
all right.
Oh, so it is really, you know, uncomfortable for you right now.
Yeah,
Right.
I need to close the windows first for.
Alright. So okay, guys. So we are in the middle of pause because Andra has something to do, and so we were going to discuss about this. Yeah. So here's Andra. He's back
Yeah,
again.
let's go again.
Yeah.
Okay, I'm back.
So it
All
is
right.
it is your neighbor, Andra.
What?
That's your neighbor who use
Yeah, I mean
mosquito repellent.
maybe the airway instructs the fogging programs right now as
Oh,
the
so
mosquito numbers are now increasing.
oh, I see. I get it. Also, you're like drrrr sound in. Yeah.
Yes, you're true.
Oh, I see. Going.
Okay, let's continue it.
Plus
Oh,
mg resulting into 2ag
2 AG and plus.
plus 2 mg. Mg is 2 plus.
Yeah.
Okay,
Should
check it
we
first.
add to the EV
Sorry.
the voltage? Shall
Oh,
we
okay, yeah,
add it?
we're gonna uh calculate the amount of faults later. Okay, but now we already got the complete reactions between silver and magnesium.
Okay.
Okay, great. And uh, from that point, I mean, we need to rewrite about the faults between the silver and magnesiums. Okay,
Mm-hmm.
so what is that? The magnesium. Alright, can you guys give me a clue about the fault between two of them?
I think it should be first you need to the silver needs to be the voltage of silver you need to times 2 because you add 2 you to balance it. So basically from 0.8 to 1.6
Hmm?
positive, and then you add it into the mangan, right? The is it magnesium? No, right? It's mangan.
Mangan is Mn actually.
Yeah. So sorry, this is the magnesium, right? So basically the magnesium will be still minus 2.37, and then you added those number to resulting into 0.77 voltage
Hold on,
negatively.
hold on.
Negative 0.77, I guess. That's my guess, I think. Uh
Uh, all right. The first about the silver. What is the fault of silver?
0.8,
And then for magnesium,
2.7
minus is it
minus 2.37.
okay? After we have this, after we have this, we are really concerned about the rules. Okay, the rules to make the calculations of voltage. Okay,
Right.
um, the rules is like this. Okay, so E E cell, okay, E cell equals E cathode minus E anode.
Anode.
Yeah, or we can say like this: a
So it's
cell
adds up.
equals a uh, reduction
Oh, so it
minus
add up.
a oxidations.
So 0.8 minus.
Plus
Oh yeah, plus.
2.37.
Oh yeah, yeah. But 0.8 should be multiplied by 2, right? Or not?
Yeah,
Well,
that's
I
what I
think
wonder.
we don't need to multiply it.
Oh, we
Oh,
The
don't
so
need
it
to.
doesn't.
multiplication
So
just happens for the uh, reactions only, not for the voltage. So I mean, there's no relations between the multi multiply and the fault because it just happens for the reactions, not for the I mean the complete fault
Oh,
calculations.
I see.
So what is
Oh,
the calculation, guys? Uh,
basically 0.8 plus 2.37. So basically 3.17, I guess. Tell
so
me if it is
sorry,
true
sorry,
or not.
sorry, then. What is
3.17.
3.17?
Is that
Uh,
correct, Andra?
is there any minus?
No, I guess because
yeah, I
minus.
think that's true. No, yeah.
Okay. Yeah, it's very true, man.
Very
The fault is the plus 3.17.
Yeah, because the if you talking about voltage, you mean it means the difference potential, right, between the higher and the lower. It's like looking at the elevation between the positive one and the negative one. Let's say like you have a waterfall, which is
Okay.
you have the higher elevation and you have the position of the lower elevation. Let's say the lower elevation has minus there, but if you want to see the difference, basically you add up the difference. Basically you
Now
add
that's
up.
what we call as a potential energy.
Yeah, I think that's the best analog to this sorry, to this EV, the voltage.
potential charge, right?
Yeah,
Yeah.
potential charge.
Yeah,
Oh,
I couldn't
that's
agree more
interesting.
than you. It's true.
I usually hate I don't like chemistry because they have their own set of rules.
Yeah, it's not as free as math, right?
Yeah,
Right?
is that as we was right?
Math
Yeah,
is
Oh, you
more.
think that is more free because of that?
I mean the rules are pretty much consistent, right? We don't have to learn new rules, right, in math. But yeah, in this we still have to
Use
know what rules
memory.
apply. Yeah.
Yeah, use
All right.
memory.
Now we are experiencing about the cell notations. All right.
Okay.
So
Okay.
from
So
the cell notations, I think you need to put first anode and the second cathode.
all right.
Yeah, I mean I will make it much easier for me. Okay. So from this example, okay, we have anode. We have anode. What is the anode, guys?
Anode is for the oxidation.
Okay,
Mhm.
so is that magnesium or
It is the
Ag?
magnesium.
Argentum. Magnesium. All right. So simply you see uh, magnesium is like that, and then for the argentum, which is the cathode, right? The cathode is like this. Uh,
Oh, I see Ag plus
plus
Ag. I see.
yeah, yeah, it represents the whole reactions in just one simple notation.
I see. I see. That's the
Yeah, that's
notation.
the how we can say yeah, the notations.
So you mean you see? I have just learned about the idea about engineering,
Oh,
and yeah, it is from software engineer course, like what I learned in Wednesday before. And
Mhm.
do you know why there is an engineering in stuff, Andra?
in what way? Sorry.
So you see, why is there a concept called engineering? Why engineering? The word engineering exists.
It is because uh, engineering means that you need to follow the set of rules given from the factual research. Is that
Yeah,
true?
that's right. Also, is there another reason why it is called engineering?
Randia must know about it.
No, I don't really know, but does it use engine? No.
No, no, no.
Okay, it's not about that.
Hey,
Okay.
but you are also computer engineering, right? But as
I am computer scientist, not computer engineering.
Software engineer.
So okay, software engineer. I don't know because
like
if you use designing or stuff like
computer
that,
science
I don't know.
is some computer science is not as the same as software engineering. Okay, I get it.
Yeah, it
That's
is very
different.
different.
That's different.
But how what is it like? What is why is called engineer? Because it's
Oh yeah, yeah.
design.
Why is it called as a engineering?
So you see, before there is this when first of all, what is the what is the earliest engineering uh, field in the world? You know, what is the first engineering in the world?
Uh, Engineering. It is
Maybe architecture,
yeah,
Close.
chemistry,
No, no, no. Randy,
building stone
civil
X,
engineering,
what? What
civil.
Andra?
building tools,
What is it, Andra?
civil engineering.
Yeah, that's right. Civil engineering.
Yeah,
Oh,
Andra
Randia, you
said.
are right.
Yeah, Andra said that
Yeah,
civil
yeah, that's
engineering.
yeah. Civil engineering is the first engineer, and then later on, what is the second engineering after civil?
Chemistry.
No, no, no. My at least my teacher didn't say that. Not chemistry engineering.
uh,
Maybe architecture. I don't know.
No,
Building
no,
house,
not.
building.
Machinery, mechanical.
Yeah, that's
No,
right. Mechanical
is it
engineer.
what?
So mechanical is not just engine, Randia. It
All
is
right.
more
Yeah.
basic. You know, like how roda. What is roda?
Oh, uh, wheels.
Yeah, wheels, and then yeah, wheels and stuff. You know, like water turbine. It is mechanical engineering, not not only machine stuff. Although it is like machine, right? When we thought about
Hmm.
mechanical engineer. Yeah, and so why? So actually, first of all, computer scientists make like for example computer, right, or at least chemical, chemical, make it chemical. So at least someone try something about chemistry, right? So they mix something up and then boom, that's chemistry. But
Yeah,
it has
I mean,
its
chemistry fields used to be announced as the uh, mysterious formula, like
yeah.
uh, the chemical compounds, is was understood as the what is that the course man or the elixir elixir
Alexia.
or uh, our medical cure medicines or yeah, at least the people are still not familiar about it back then.
Yeah, so that's right, Andra. So at least first of all, there is this guy trying to make something up, and boom, it becomes something chemist, right?
Yeah,
Chemist, but
it's magic. Yes,
that's
magic.
not engineering yet. That's not engineering yet. No. Why there is this word engineering? Simply because we want to scale it up. We want to make it large scale. So that's why there is a study about engineering. Engineering is about making it large scale. So when we talk about software engineering, it is basically making a software in a large scale. So when you study about chemistry and engineering, it should be about
Chemical engineering.
how to make a large
Yes.
scale chemical stuff, right?
Oh yeah. You're very right. That's
Yeah,
why it is different with the pure chemistry or pure uh, physics, pure mathematics, because uh, instead of inventing the right rules or patterns of chemical reactions, we just have to scale it up into the plain designs, at least.
yeah. I'm
Mm.
kind of curious. What is the biggest uh, chemical plant in the world, Andra?
The biggest
Well,
chemical plant, BASF.
The ISF. What is that? No, that stuff must be super engineering, impossible engineering.
All right.
Do you know that show?
I will I will share or show it for you.
Uh,
The biggest chemical plants.
do you know a show, TV show called Impossible Engineering?
Is it from the geographic
Yeah,
nation?
from Geographic or Discovery, or I forgot.
All right, here, there you go. You can see BASF.
Oh, so this is the biggest, you
Yeah, I
know.
used to wanna do internship in BASF in Cikarang, but
wait,
since
in Cikarang?
since it was still the pandemic time, so I mean, sir, they uh, smoothly rejected me. Yeah, I mean, yeah, there is BASF plants here in Cikarang, Rendia, and
Oh,
it
I
is
haven't.
located in Jawabeka, uh, Jawabeka
Area.
Industrial Estate,
Area.
okay, near Hot Wheels or
Okay, Neil Mattel. All right.
Metal. Yes, it's Metal, near Metal, man. You can see there's the massive uh,
Plant.
chemical engineering devices like the pipes or the, let's say, the tank, the reactors inside the plants. Yeah, that's awesome. But SF actually produces a lot of chemical variations. There are about 200 production plants on the site manufacturing thousands of different products.
All
Oh
right.
my God.
And
Yeah.
then next BASF in Nanjing. Next,
Oh, but you know the what is it called? The biggest one in Southeast Asia that you put in your thesis is that chemical plant too, right?
okay, the biggest chemical and chemical.
Like in your thesis, you say that you going to what? Sorry, again, I forgot. Like you want
In my
to
thesis, I'm about to build the uh, man man or malic anhydride uh,
in the
in
yeah
Indonesia.
Indonesia basically. Yeah, something
Yeah,
like that.
and it's just, I mean, I set the production's scale is about 14,000 tons per year.
14,000 tons
Yeah, per year.
for a year. Oh
Yes.
my God,
Thousand.
14,000. Wow. Like how massive it is. 14,000.
Well, I mean, it's still small because in the previous paper, I already saw it is 25,000 tons maleic anhydride per year. But because I heard from the rumor, I mean, the man
Hmm.
is mostly
The
imported
mill.
from China. So I mean, the market in Indonesia is dominated from China. So the local manufacturing is now struggling to face this
Compete.
kind of problem.
Oh yeah. So Cikarang people is struggling right now because China.
Really?
Uh, yeah, I mean it's the only producer that's still producing the malic anhydride in Indonesia is just PT Justus. Uh, if we compare from the last 5 years ago, there were several companies that produce the chemical, but now it's still just left the PT Justus alone. So I think China is really bombarding Indonesian's market with their massive products. So yeah, we need the protection from the uh, Ministry of Industry.
Oh, Erick Thohir. Oh no, Erick Thohir.
Clear.
BUMN. No, no, no.
Is BUMN, state-owned enterprise, but uh, he has the second job as the chief of Indonesian Football Association.
Oh, I see. Yeah.
So yeah, double wages.
Oh, no, 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 no. Wait, wait. Oh, yeah, yeah. Okay. I see. So back again to our topics about uh, voltaic cell and
Hmm?
stuff. With engineering, we you know alleviate that concept, right? That notation AG slash slash AG plus slash slash MG2 plus
Hmm?
slash MG. Back again to your presentation again, Andra, please. Can you? Yeah, I mean, so people in engineering use this simple notation and they literally scale it up, or what? Oh, it is both.
Uh, yeah, I mean it's just all about the electrochemistry, which is a branch of chemistry. So it just in this pilot scale, it hasn't been scaled up yet, but yeah, it's just a basic science of electrochemistry. Um, I mean, I want to show you an example of the. I want to show you another example of voltaic cell, but I'm afraid if the time is not sufficient, so I rather just show you some or one example of it from
Okay.
the magnesiums and the argentum, voltaic cell. But what I wanna enhance you is that I hope that at least you understand about the basic of how we can calculate the volt of cell.
I see.
Okay.
Voltaic cell from
Yeah. From the
electrical chemistry reaction.
chemistry to electricity. Yes.
Oh,
So most of the electrochemistry compounds are toxic. I mean, uh, we have magnesium, argentum, which are known in Aki.
oh, I
And
see.
when you just waste the water on the water body of river, then you will be arrested by the government.
Really? I
But
see.
there are
Yes.
so many companies that do that, isn't it?
Hey, do you know that one of my how can I say? My dad has a friend, and that friend has children
Hmm?
as a kid. Okay, as a boy, and that kind of boy uh, is now having the broken liver.
What? How can
Broken.
it be?
Yeah, because he consumed the water that was contaminated by HU water.
What? In when they went outdoor or
Yeah,
how?
uh, he used he used to live in Purwakarta, and he actually, what is pulling water up from the well.
Oh yeah, 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 yeah. Like
Yeah, but
groundwater.
yeah,
Releasing groundwater.
groundwater, yes, that's right.
Mhm.
And the groundwater is already contaminated with the HE water that
Oh.
some irresponsible people simply just wasted the HE water in the grounds, or yeah, the area near that kind of neighbor. So
Mhm.
yeah, the worst case happens, like two children are sent to the hospital or hospitalized. uh, his his older sister, was safe at the time without any broken organ, but the worst case or the worst thing happens for the younger brother, which
Mm.
now has the broken liver. So he has to be what is that? Cleaned. The blood of him should be cleaned every month, or I forgot about it. But yeah, I
Oh,
feel
that's
sympathy for him, because from that I can see his face is always dark, man. I mean, like lesu. What is it, lesu?
yeah. Pucat. What is pucat?
Pale.
Oh yeah,
Yeah,
pale.
yeah. It's, in addition, if the blood is already dirty, because of his liver is not functioning well, so the blood is dirty when he do not get cleaned in hospital of
Mm.
of his blood. Yes, it's really you know uh, it's
Unfortunate.
really bad. Unfortunate. Yes, yeah. I feel bad for him. Yeah, but the family always struggle to clean his blood every month.
Oh, sorry, what is it
Jidara,
called?
jidara.
Dialysis. Dialysis, right?
Dialysis, yes, yes, dialysis.
That's liver, isn't it? Ginjal, man. I'm not sure.
Not
Ginjal is.
necessarily.
Hati. Ginjal is not liver. It is ginjal is ginjal is kidney. Yes.
No, yeah, but
So
dialysis. I think dialysis is not supposed are not just for
kidney,
kidney, I
but
guess,
also
but
for heart,
also
for heart,
yeah, I think
or liver,
that's
for liver. Yeah, for
probably
liver.
important. Well, I mean, it's just cleaning your blood, right? So it doesn't really.
Oh, I see, I see.
I think that's
Yeah, and you can
uh,
see from the chemical compound of the HE water or lead acid battery. Okay,
Oh,
timbal or plumbum or lead, and isophore timbal again. You see, lead oxides, lead. Yeah, you can imagine how toxic it is.
oh, so there it contains lead.
Yes, from
Oh,
the
from the battery.
AQ, yes,
Oh, I
and it
see.
has 2.1 volts from the nominal cell voltage, as I see here. And yeah, the point is that yeah, we need to be concerned about the environment before we establish the very toxic
Environment.
chemical
Yeah.
compound plant.
hmm.
I see, I see.
Usually that I with my friend go to go to the not the uppermost, like to the what is the opposite, what is the English of hulu? I don't know, I don't
Bank.
really.
Downstream,
The
downstream.
bank. Oh, downstream.
No, the upstream,
Oh,
the
the
opposite of,
upstream.
yeah, the
Oh yeah,
upstream.
upstream,
Yeah,
upstream.
Hillier is the downstream,
Downstream.
and yeah, I tried with my friend going to the upstream of Kalimalang.
Oh,
And
seriously? I have no,
yeah, yeah,
I have no idea.
yeah, we had some adventure to see like where this is come from. So it mixed up with Citarum River, and then after that we go up there, and that we saw some textile plant dump their
Oh
chemical
yeah, I got it.
into the water, basically. Some regulation,
Okay.
yeah. I asked some locals there. They say that some of them have their uh, some of them follow the regulation safety. In Indonesia, some of them just bribe.
Exactly.
Yeah, they say
What
they say they
the
bribe the government to look other
driving?
ways to from the chemical, something like that, which is very depressing to be
Yeah,
honest. But it is interesting. Yeah.
yeah. The the majority of waste in Citarum body water is from the textiles industry.
Yeah, textile industry. Many of them is the most
Like
leading.
yeah,
Yeah, the most
Adidas,
leading
Uniqlo.
is textile industry rather than other type of chemical plant.
I
Well,
Yeah,
I
see.
no,
mean, it is chemical plant, but it
yeah,
is.
no wonder that Citarum sometimes change its color to be.
Yeah, yeah.
How about Chili Wong?
I haven't go there yet, but it is
But
very.
Randy, when when I uh,
Hmm?
ask you to get in Bogor Botanical Garden,
Yeah, yeah, yeah.
could you see the river under the
I
uh,
saw the river, but I
yeah,
don't
it
think.
is called as a Ciliwung. It is Ciliwung actually.
Oh, it is Ciliwung. Okay,
Ciliwung is
got it.
still clean, right? In Bogor.
Oh, Bogor is the source of
Yeah,
Chili
the
Wong.
sort Ciliwung. I guess,
Yeah,
yeah.
yeah. I mean, uh, as the river gets along until Jakarta, I mean, so many sources to make the Ciliwung dirty.
Oh, I see.
From
So,
upstream to downstreams, in the middle of downstream and upstreams, there are many chances to waste Ciliwung about many both chemicals or uh, solids particle
Hmm.
waste.
I see, I see. So I
So
guess,
yeah,
guys, I guess because right
Yeah.
now it
okay,
is already 15 past 9,
all right.
we're going to close this podcast. So yeah, today we learned about Voltaic cell. It is basically to measure the the fault, the what the fault, the
Yeah,
Basically, it
yeah,
the
yeah.
converts chemical energy to electrical
yeah,
energy, and Andra
exactly
shows.
how chemical energy is converted to electrical
Electricity.
energy,
Yes.
and there is this calculation about that, a
What the
theory
fault?
about that,
Yeah,
and yeah, so we know about that right now, and it becomes the sources. It becomes the source for battery and stuff. Oh, so here is Randia's note take minutes. Yeah, that's really cool, Randia.
No, I thought you want to summarize everything. So,
Oh, so
yeah,
yeah,
yeah.
that's nice.
it's
Not
kind
actually.
of yeah, I guess. So
Oh,
I
yeah, okay.
guess that's all from us. Thank you so much for coming here, guys, and for the viewers, if it exists.
I think it sometimes they are exist, sometimes they are not.
So yeah, assalamualaikum warahmatullahi wabarakatuh.